Hello there. I got COVID. And like half the population, I felt terrible. I was sick, I couldn't do anything. Everyone around me just ostracized me and said, never want to see you again. And I decided it was time to make this everyone's problem. So I decided to make a robot. And let's say I made mass detection with pain. Stay with me. So now you might be thinking, how the hell am I going to do this? So I call this mass detection with pain. The main thing here is that second part, the pain. What do I need? A robot. Guess what I got for you? Boom. The robot is made. Does it even work though? I actually have no clue. Your answer's right there. Let's see, movement. Okay, the main point of this whole thing. Does it even shoot? We're shooting these little things. Squishy little Nerf balls. I forgot which button shoots it. Is it this? This? Okay, well, fair enough. There's your answer. It shoots. Now you might be wondering, how did you just movie magic and make this thing appear? Well, this, that thing I threw away. Yeah, and all of this. Yeah, prototype 1, prototype 2, prototype 3, and about 4 other prototypes, which I think I have burned or thrown away. And then part of the prototype, the camera mount. There's a camera for this stuff. You gotta see. But yeah, camera prototype 1, 2, another one of these little plates, and I don't even know what else. So, am I gonna explain the build? So now I'll go into how this actually works. So basically we have the upper part and the bottom part. So the upper part has an area for the projectile to be shot out of. And what happens is this 6,000 RPM rev orbital motor powers this wheel over here. And if you load a projectile into the back, it gets shot out through this area, which acts as kind of like a guide. And then in order for us to be able to hit any person we see, we have to be able to move it horizontally, which is powered by this turntable at the bottom. This one torque servo allows us to turn side to side, so we can get all horizontal movement. And then we can have 2 35-kilogram torque servos, which allow for us to go back and forth, so we can hit any height we want to. And with all of this, we can now get into the harder part, which is the coding. So now, let's get into the harder part, the program. So our program uses the idea of heuristic programming, which basically is a smarter algorithm which uses previous data to basically kind of guess almost. And it makes an educated guess on anything that you give, and there's not a set solution or algorithm to anything. This allows for us to possibly detect many cases, like cases which we don't account for, because different people, we can't account for everyone. And so to start off, I did not know how to train a model before this, so I actually got a lot of help from the video, which I think I'll put the link up here, by Nicholas Renate. Sorry if I butchered the name. But let's get started. So how exactly did this work? So first thing we did was we got a data set, and this is just a ton of images, and you just get as many as you can. And what we did is we went through them and we labeled each of them. What is labeling? We basically go into the image and we find the part where the person is wearing a mask or no mask, and we highlight that and we tell the image that, oh, this has a mask, this does not have a mask. And this is done in the form of an XML file. XML files keep the data that we put with it, so the no mask or mask label is kept with that. And basically from these labels, we are able to break them down. Now that we've labeled everything, we can break down our data, which is all of our images, into training and testing. So for the case of our model, we decided to do an 80-20 model. So we took 80% of the images, put them into training, 20% of them, and put them into testing. Then we get to so far this has been working with the images. So now we're going to get into the actual coding part. And basically the first thing we did is we have to create our labels. So in our case, we only have 2 labels, mask or no mask, because that's the only thing that could happen in a human being. And what we were able to do with this is we create a label map. This label map is in this thing called a protobuf.txt file, which basically allows us to go across any machine because it converts it to binary. So we don't have to worry about whether it's Windows, Mac, any of that stuff. And from this, we're able to make our TF records. TF records is something that's really important because it really stores all our images in a binary format. So it keeps all our images universal and we can open them up on any computer, any device, anything. And this actually took quite a while because we forgot to download the TF API, kind of a problem. And then we got to the actual training. So what we had is initially, we had a data set which had 15,000 images in it, which is a bit too much because that was expected to take about a week, but 3 days into the process, internet cuts out. What do? We have to restart it. It's not efficient. So instead, we utilized a transfer learning method, which is actually talked about in the video by Nicholas. And basically this uses, from the TF model zoo, it takes previously trained models and it kind of builds off of them rather than trying to start anew. It's like, take for example, a student. If you have a student helping another one who has already learned all this material, they can give certain things to the student that a textbook might not be able to give to it. So it makes the student learn faster. And basically we use something called SSD MobileNet, which is one of the many things found from the zoo. And it has a low MAP, which is the mean average precision, because we don't really care for precision. We want our thing to detect quickly, and precision was kind of a secondary factor which we didn't care too much about. And after we chose this, then we had to change the config. So the config for our model is essentially just the instructions to train. And now that we've chosen like a transfer learning module, we need to now change those instructions to, first of all, we want to use the transfer learning from the model, so we have to point to that model. And also we have to point to the other things, such as our label map, our TF records. And with all of these things, then we can finally start the training. And now with the training part, we have to go back to our images. So in our images, we had our training and our testing. And so what we're doing is we have to break these down into things that the computer can learn. So our organization for this was we took 4 images from the training, 1 image from the testing, and we would use that at once. So basically the computer will go learn from the 4, test from the 1, and it'll get like an accuracy. And repeat this 100 times. Each of these with the 4 train and the 1 test is called a step. We had 100 steps. So what we're trying to do is we had a total of 682 images, and we wanted to get through as many images as possible. So in all, this would get through about 500 because we have 5 images per step and we have 100 steps. So we're getting through a good amount of the 682. A better version would have been if we chose 136 steps, because this would get through all 682. But we don't have to worry about that actually, because we have another thing called an epoch. The epoch actually is how many times we repeat the entire thing. So we are currently testing 500 images, but you have to take into account that we have 50 epochs. So we're going through those 500 images 50 times. And basically the point of the epoch is to keep learning, because the first time you do something, the second time you do something, you're not going to be successful. You're not going to have that accuracy. And we're aiming for about a 0.15 accuracy. And our model actually successfully got a 0.07 accuracy. And so model overall works. And now that we've trained it, we have this thing called checkpoints. And these checkpoints essentially allow us to go back. It's almost like in a video game, like a save point. So we don't have to do the whole model learning and training again. Rather, we can just go back to these single checkpoints and start the model so we can go and detect whatever you want. So now we'll show a working example of this. So now you might be wondering, so why does this work, right? Because I've shown the code, I've shown the code working, I've shown the robot working, now you just gotta put them together. Or so I thought. The reality of this is you have to actually look into the brain of this thing before you make your complicated code. So the code's great, the robot's great, they work completely fine. But the main issue is this thing here. This thing where, making it look like a bomb, that's where the wires are connected to, and that's like the brain of this robot. And big issue is that the TensorFlow, which is basically taking care of all the vision and all the detection, we're using TensorFlow 2.0, which is newer version. It's a lot better, and it's what allows us to do all these heuristic programming, which makes us account for things that we can't currently account for. Sadly, the control hub can only support 1.0. Not the best, and it can take care of things that is more of detection. This is like if I was to take an image and I'd say, is there a person wearing a mask? I could say yes, or I could say no, but I can't pinpoint where they are. I can only say that they're there or they're not. That's the most I can do with that. On the other hand, with our model, we could say they are and they're here. So then after that, we could coordinate our motors to turn side to side, up and down, to point to that, and then we could fire the mechanism. Sadly, that won't be able to work with this, but overall, great learning experience. Learned a lot, and I know it sounds cheesy as hell, but yeah, it was fun. It was painful, very painful. 3 weeks of a 3D printer, fan, non-stop running. So many fails with this thing, I can just snap this in half and sweet, as can be seen here. So many failures, some successes, great experience. If you like the video, I don't have a channel, so don't come back. Yeah, I hope it was fun to whoever's watching. If you're not entertained, I don't know, throwing stuff, hopefully that entertained you. See ya.